My name's Nethaneel Edwards. Some people just say Neil. If you know me really well, you can say Patron, you know. As they say in my country, what say or in your country, que lo que con que lo que, yeah? Nice to have you guys here. So I am a staff software engineer here at Google. What I do, I write code. I design docs, I review docs, I do a lot of different sorts of designs. But my journey into engineering, you know, it's an interesting one, but today I want to focus more on you and empowering you to actually build some cool architecture and use a few of our slick tricks. What actually inspired me to even come up with this presentation, which I just want to briefly touch on, is I build, my role in particular, my team, we build a lot of large-scale infrastructure for Google. You know, Google is pretty big, you know, like over 160,000 employees. Even recently with the deployment, I know we sustained over 30,000 queries per minute over a large window. So that tells you that our infrastructure has to scale quite a bit. But building these tools, sometimes we discover these cool, slick tricks, but I can't get to really talk about them because I'm doing it internally. So I had to be honest with myself and ask, how can I do what I do internally if I didn't have all the cool toys I had, aka using purely external tools? And that's what got me curious about Google Cloud and developing on Google Cloud what I do internally. So to be clear, I'm not a cloud DevOps engineer. I'm a software engineer that got really curious about Google Cloud, so I can share with you a few slick tricks about that. So we're going to get to talk about one of the slick tricks which I really love, which is long-running operations and how they fit in your architecture. Or put differently, how can I make something that's pretty slow seem pretty fast? So I'm going to split the presentation up into 3 sections. We're going to help educate you on what long-running operations are, why would you want to use them, what are the problems they can solve, and then after that we're going to try to visualize it a bit. I want to set up the presentation in a way almost like you get to go through my design process with me, and from there we get to the real cool part where we do a code walkthrough. I'm going to log into my Google Cloud Console, and also you'll get to see my public GitHub repo so that you have it as a reference, really for code snippets if you're going to do something similar. So now, when we talk about the long-running operation, it can really be summarized as a way of representing an action that takes a significant amount of time to complete. So a significant amount of time is relative. To me, if I'm doing an action on the UI and it's taking 10, 30 seconds to complete, that's a significant amount of time. I really would prefer if you complete in a second or under. But that's just me. You know, it's going to be subjective to wherever you're going to implement your LRO. So now, I want to give you some clear examples of what's an LRO, or where would an LRO come in handy. Let's take, for example, compiling code. What if I was compiling my code and I didn't have to wait and watch it compile? I can probably get a notification that, hey, the compilation is done. Or, you know, growing up in the Caribbean, so I forgot to mention that, I'm also from the Caribbean. I'm from the island of Antigua, just right around the corner from you, not too far. But I live in Austin, Texas right now. And so, growing up in the Caribbean, you know, we have different processes for the way we do things, and there's a lot of room for technological advancements and optimization. One of those is, let's say I'm trying to generate the paperwork associated with your payroll. So in Antigua, typically, you know, you have to generate the forms for education levy, social security, medical benefits, and your pay stub. And imagine an application where you click on the employee and then you have to wait on those pieces of, let's say, a PDF being generated or whatever it is. Now, imagine you have 100 employees. What are you going to do? Click through those employees one by one and wait? You're just wasting your resources. And then someplace in the DR where your population clearly eclipses Antigua's population. So now if you have a very profitable business, I wish this on all of you, maybe you have 100,000 employees too, you know, you want a way that, hey, how can I say, generate this information for my employees and I can trust that it eventually will complete. You know, I don't want that eventual guarantee. And you can start to envision an LRO as just a graph of dependent operations that you're waiting on to complete. And we're going to visualize that even more. My friends that know me, they know I have this personal philosophy. It may be wrong, but I still stand by it. I believe a graph can solve everything in life, engineering or not. So that's the approach I look at. So I'm starting to give you another example of an LRO here. So as you can see, this is an example. Let's say I'm trying to index a book, and this is a legit LRO. There are a few operations that I probably want to do that I can wait on to complete. I want to fetch the content. I may want to associate some metadata with the content, maybe notify the subscribers. But at the end of the day, it's only when all of those sub-processes complete, I can mark my LRO as done. So I have my pigeons here because carrier pigeons represent a messaging system. So if I have a group of pigeons that I gave a message to carry, I cannot say the task is done until all those pigeons get back. And that's how I really envision something like an LRO. Now, as we start to approach, hey Neil, how do you actually implement this in code? What does it look like? I need to just quickly touch on a little architectural concepts so you can better understand. How many of you here are familiar with Kubernetes? Great. So what you may not know is a lot of the engineers that were on the Kubernetes project, they came from Google. In particular, they worked on the Google machine called Borg. And so Borg is very similar to Kubernetes. We have the concept of a cell, which can have a set of jobs, and the jobs can have a set of tasks. And you can say, hey, what's a task? A task is what's going to have your containerized application itself. And then you replicate that application, and then that gets grouped into a job. I can then now have this job running in a cell, and cells exist in locations. Cells are like clusters of machines. Cells exist in zones, and zones exist in regions. Regions exist in metros. And so that's how you get your distribution globally. And a collection of tasks that run on the same machine, that's seen as an alloc because an alloc provides those shared resources that those tasks use. Now, if I overlay this on top of a Kubernetes system, it's very similar, except that Kubernetes has a few more improvements, you know, such as you can use labels for organizing pods, and there's an IP per pod concept instead of having all tasks share the same IP in their alloc, etc. But I want you to just keep this in mind in terms of the distributed nature of Kubernetes, because that's going to come into play when we start to hit on our LROs and executing those jobs as they go out. So now we get to start the design. We're all working on this little project, and this project, we're just going to do an example of compiling a book, so to speak. It's very simple for the most part. So first thing we got to look at, hey, what are the least amount of components you're going to use in Google Cloud also as an example for getting this done. Remember, I mentioned earlier I wanted to see how can I translate this cool trick to Google Cloud, so I needed to see what components I needed to work with. And I selected the main ones. Kubernetes for deploying my app in a distributed manner. I included Cloud Spanner, which is so fun. I'm really excited to get to talk about why I chose Cloud Spanner. But that's for my database storage. Cloud Pub Sub for my messaging system. And we're going to see how cloud endpoints play a role later on. Cloud endpoints are not really needed for this, but it's a good practice for a reason that we'll get to touch on. So, Cloud Spanner, why did I choose that? So I could have chosen a few other database storage solutions. I could have chosen Cloud SQL. You have options such as Firestore, Bigtable, all of these things which I'm sure you've heard about. But Cloud Spanner, that's what the big boys use. You know, you get 5 nines of availability, yes, and you get that transactional consistency, and it's native to Google Cloud's network, so you get an extra low latency. But one of the cool things I like about it as well is the concept of interleaving tables. So interleaving tables is where I can have a parent table and have a child table, and as a result of saying this child table is interleaved in the parent, that's going to tell Spanner that, hey, I have child rows, do your best to group these child rows together with the parent row. Because databases like these, they call them block storage systems, and that they get distributed. But what you want to do is when I'm making my query, I don't want to waste a lot of time going all over getting those child queries from different locations. I would like them as close as possible to each other to optimize the query. So that's why you'd want to use table interleaving for that. That comes in handy, which you're going to see in my database design for long-running operations. Because in an LRO, you're going to have your main operation itself, and the dependent tasks or row entries, those are going to be child tasks that are interleaved on the parent table. Now, that's one cool thing. The other cool thing is the row deletion policy. That's the ability to put something like a TTL on a row level. When I design long-running operations, I love using timestamps a lot. The creation timestamp, modification timestamp, and for an LRO, the completion timestamp. The reason for that is the completion timestamp becomes nullable at the beginning. It's obviously not populated until the record is completed. Yes, I could have used a Boolean to say it's completed, but the same way I can say, hey, is there a completion timestamp indicates that it's completed. Now, when I say my row deletion policy is set to a certain interval, I can say row deletion policy on the completion timestamp, set the interval to 3 days. And now my database knows that as soon as 3 days has passed since this LRO has been completed, clean that record up. So now my database is just automatically compacting on its own, even though I have a lot of operations running. So just on an architectural level, I've already designed something efficient. So that was the Cloud Spanner I told you I was really excited about. Now, there is cloud endpoints. Why do cloud endpoints matter? And I'll touch on that maybe a little bit more depending on time. But essentially, cloud endpoints provides me with a way to build on OpenAPI, which Jordan actually just spoke about in his talk. And I can actually say, hey, for this endpoint, I only want to allow this many queries per minute. And so I can start to do some load control in that manner versus you're building a distributed system. I can't say I'm going to put a throttler in per task because let's say I'm integrating with a third-party API and they said, hey, Neil, you can only hit me with 100 queries per second. So I said, it's okay. I only got 10 instances anyway. I'm going to just set the throttler for 10. Now I have incoming traffic on my side. Kubernetes starts to scale up automatically. I no longer have 10, I have 20, and I'm hitting twice the amount of traffic. You know, that's not responsible integration. But a better way now is if I use OpenAPI and combine that with cloud endpoints to create that actual spec that I can say, hey, don't send any more than this amount of queries per second to this endpoint. And that resembles the concept of a global system throttler, essentially. So when you're doing cases like this where you're doing LROs and maybe you're sending a lot of tasks to your microservices, that's where cloud endpoint comes into play because now you want to balance the load a bit. So let's look at our database design now. Oh, before I jump to that, Cloud Spanner, how many of you here are familiar with PubSub? Okay, so let me not glaze over that. So Cloud PubSub is an implementation of the publish subscribe design pattern where it essentially says, hey, I'm going to push a message to a topic. There are certain people subscribed to the topic, and those subscribers, they're going to get a phone call from me with the message, essentially. So it gives me a centralized way to push notifications out to systems. And we're going to see how that works. So now we got to see the component model. I want you to take a look at, this is what an LRO can look like on a database level, a very simple implementation. So the book compile operations, that's going to be the table that stores my long-running operation. As you can see here, I have an operation ID. It can be any unique ID, depending on whether you come from open source or closed source, globally unique ID, university unique ID, a GRID or UUID. It can be that. The operation status, something simple as not started, in progress, or complete. And remember those timestamps I told you about? Timestamps are your best friends, especially for debugging. So you can see my creation, modification, and completion. The book queue. Now, typically when we do long-running operations inside of Google, we have the advantage of using something called a spanner queue. A spanner queue is essentially, it looks like a table like that, except I can attach an endpoint to the table, and literally it's going to try to push a payload to that endpoint. When that endpoint acts the message, then it automatically removes from the table. Now, spanner tables are not available publicly. I can talk about this because I Googled it and I was able to find it. So obviously it's out there already. So it's not available publicly, but two things. Cloud Pub Sub is actually built on top of spanner queues. That's one thing. And two, there is another Google Cloud offering called Cloud Task Queues that I could use. So you may say, hey, if you're familiar with cloud, you may say, why didn't you just use Cloud Task Queues? For my example and the kind of person I am and the latency I'm looking for, Cloud Task Queues, it pushes to an App Engine endpoint or an HTTP endpoint. My design, as you're going to see as we go into it, I use gRPC, which is Google's version of RPC. It's built over HTTP2, message compression, and a few advantages. And so I know I wouldn't really be able to push to that endpoint, and I'm like, there's no need for me to hop out and hop back in and all of that. So I kind of get the same behavior anyhow by putting a record in the book queue, publishing a message to Cloud Pub Sub. Pub Sub then sends it to a subscriber who acts on that message in the queue. When it completes successfully, it removes the message from the queue. The LRO checks to see, do I have any more items in the queue? If not, mark it as complete. Like, wow, Neil, that's a lot. Can you walk me through? Well, I knew you were going to ask that question. So I decided to give an LRO sequence diagram. And can you guys actually read that or no? No, oh no, okay. So it might just be the presentation screen. I'm going to try to see if I can zoom in. Nope, so Control plus does not work. Pardon? Yeah, I'm trying to pinch and it doesn't zoom in here. Let me see if I can. Oh, and it is full screen. What's that? Top right. Oh, in Chrome options. Okay. All right. Oh, yeah. So I knew that, but I was testing you guys to see if you knew it. Oh man. So the zoom did not work there, unfortunately. So I am going to try to explain the LRO as much as I can. I'm going to come down and walk it through because I know exactly what's happening here. So essentially, what's going to happen? We're going to have an actor and we're going to ask to get the book. And so when it gets the book, it's going to go to the book service, and the book service is going to query the book spanner table. At this point in time, it's going to return an empty results set, and it's going to see, okay, this book is not found. I need to trigger the long-running operation for compilation. So it's going to publish a PubSub message to Cloud PubSub. That's where Cloud PubSub comes into play. It then returns, that message is published asynchronously. So it returns a message to the actor that says book not found. But now the compilation has started. So now the next thing that happens is the compilation subscriber picks it up and it pulls the message. It pulls the message from Cloud PubSub. It says, all right, I see I need to start a new LRO. So it creates a new LRO entry in the table, and then it calls an asynchronous method right there to the book service to say, hey, I need you to create a book for me. Now that method is going to be responsible for doing all the work related with creating the book. We're going to pretend it's doing the compilation. And when that method is done, it's going to publish a PubSub message that says, I'm done doing that. So now I've created my LRO. The book service is doing its work. It publishes a message. The compilation subscriber gets it. And it says, oh, okay, I see you just finished compiling a book. So what it's going to do, it's going to say, all right, let me go and act that message, which is essentially symbolic for removing the message from the book queue. Remember that parent-child table? It removes it. And then it's going to tell the compilation controller to say, if there aren't any more messages waiting to be acted, go ahead and put a completion date on your LRO. And so then it ends up marking the LROs complete because we only had one book to work with. And the next time I say get book, you're going to see a sample book in the database that has pretty much been compiled. So when you say it out loud, you see that an LRO isn't that complex. It's not unique to a particular cloud, but it's more about a best practice for architecting something that could take long. Remember that thing I said about generating pay stubs for those employees and all of that stuff? That's where you'd use an LRO, because now you can see, hey, for this customer, I've included all these tasks for each employee. And only when each employee is done, it would say, okay, I'm done generating the payroll information or whatever it is for that customer. So now that we've spoken and spoken, we get to do the real cool part, which is to go over to my Google Cloud instance. And this is going to be interesting as I try to do it from here. We get to do a code walkthrough. So right now, what's happening is Google Cloud is opening my cloud editor. That's my cloud terminal. I'm going to switch to an editor, which is pretty much, it resembles Visual Studio Code. So a lot of you are going to be familiar with the UI that's going to come up. And I gave this a bit of thought, like how do I start showing you the code? I typically like to show things from the bottom up in terms of, hey, I layer my code with the persistence layer. That's what talks to the database. The controller that has the business logic, and then above that you have the service, which uses the controller. So I can do top down or I can do bottom up. I'm going to do bottom up because I'm just different like that. Let's go. I think this is it. So let's start with book service. And so you're going to see a bit of my coding style. I tried my best. I use Java at Google, at least for my team. And I tried my best to stick to the best practices that we'd use in terms of, I use Juice for my dependency injection. So Juice is a Google dependency injection library. I use gRPC for my server framework. I know some of you use Spring Boot or anything of the sort. I use Bazel for compiling my source code, where in other cases you may use something like Maven or Gradle. So I just wanted you to recognize, hey, you might see something that looks weird. This is how it's similar to what you already know. So I'm in Java, book service, let's go on the database, and persistence. So how does it look when I'm interacting with Cloud Spanner? Well, right here, as you can see, and I'm afraid to open in a new window, but let's see what happens if I do this. And if it's any easier to read. Okay, no, it's not that much easier to read. Nope. So we're going to stick to what I had. So essentially, yeah, as I was saying, so in the book Spanner, how would I talk with that? First things first. When I query from Spanner, I'm going to get back a result set. And so I need a way to transform that result set into an object that I can interact with. My typical practice, I have internal objects and external objects. Internal is what I use inside the code. External is what you're going to return to the service consumer. You kind of want to keep your objects separate like that so you don't break your users with any small change. So right here, I'm saying, hey, when you get a result set itself, you're going to read the book ID column, the column for book name, and the column for book description, and create what we call an internal book. And then it's going to iterate through the result set while doing that and return an iterable, which in our case is an immutable list. So in Google, we use a lot of immutable types to make it clear that we're not changing this after it's been created. So what I actually do here, what it would look like when you're writing to Spanner, you use these things called mutations. So now I can say, hey, I'd like to do a write builder for my mutation. I don't want to have to determine is this an insert or an update. So I use an insert or update mutation, so it will figure it out for me based upon the primary key. And I say, okay, this is the column ID, the name, and the description. And then after that, I ask Spanner to write to the database. So as you can see, interacting with Spanner is not really that complex. I have this on my public repo so that you can have it as a reference itself. And the public repo is going to be on the link at the end of the slide, so you can have these code snippets. If I find out you copied wholesale, this talk is being recorded, so let's move on. And right here, all I do, I try to get the book, and I ensure that it's present. If it's not present, something went wrong, so it would raise the exception. And that's essentially my pattern for the controllers. If you want to see more, you can always dig into that code there. Now, we get to look at the controller. The book controller is fairly simple. I inject the persistence layer. I inject a converter to convert from the internal to the external. It's really just a function that takes an internal and puts out an external. It maps them. And I also have my pub/sub controller, which is what I'm going to use for publishing the message. Remember what I said, the book is not found. It spit up a message to cloud pub/sub. So, looking at this, you can see when I actually, let's look at the get book in particular. In the get book right here, it tries to get the book. I love using optionals. It's a lot cleaner than saying if this is null. And so it essentially says, hey, if the book is present, return that book, apply the converter. If it's not, then I'm going to say, hey, trigger pub/sub request that says the book is missing, and that will actually trigger the LRO. Let's look at the pub/sub controller, because you're wondering, hey, is it a lot of work to interact with cloud pub/sub? It really isn't. I inject my cloud pub/sub config, which is just, it comes from my app config that says, this is my topic, this is my ID that I want to essentially publish to. And all I say is create a new topic for this project and this ID, and then a topic instance, and then I'm going to build a message I want to publish. You can put any amount of encoded data, pretty much, and you can even attach attributes. Here's a cool tip as well. I don't put sensitive data in a cloud pub/sub message. Cloud pub/sub is replicated globally, and for a good reason. It's high, low latency, all of that. But at the same time, I don't have control over saying, hey, I need you to publish this particular cloud pub/sub that's only in this particular zone. You probably can, but just to be safe, especially with GDPR, I don't want sensitive information going out in cloud pub/sub. I want to always have locality and control over where data is at any given point in time. So my pattern is I'll publish the ID, and then the actual applications that are consuming the data will call out to the servers and get the ID, get the data associated with that ID. So that's just a good practice. In here, I just encoded the ID. It's overkill. I could have put it as an attribute. But this is just for, like I said, example purposes. So after I create the pub/sub message, I just create an API. I added a callback here so I could see if it didn't work. But I just build it, and then I publish the pub/sub message. So as you can see, it's really not a lot. I just say, hey, publish. This is my publisher. This is a callback, and it will let me know whether or not it was successful. Now we get to go up one more layer. We just looked at the controllers. And remember earlier I said I use gRPC. So this is what it looks like when you're implementing the service for gRPC. gRPC will generate from your proto files themselves service definitions that you can implement. And so I can say, hey, when you update the book, or in this case, we're just talking about getting the book, I just inject my controller. I say get book. Is it present? All right, respond. We're good to go. If it's not present, I return a 404 not found. So now, you're probably wondering, what does that gRPC look like? I haven't really seen it before. What I love about gRPC, you can define your service in one place and generate the API definitions in multiple languages. So this is what my service definition look like for book service. I literally say, here's a service, this is the RPC, this is the request it takes, this is what it returns as a response. You're going to notice here, I also added an option for HTTP. Maybe you have people that are currently interacting with your service in REST. You don't want to break them. So then you make it backward compatible by adding I said, hey, if you post to whatever the host location is, /v1/books, your REST API will continue to work. Right here, you can see it as well that I did the get. I say this would be an option for a get, and it comes here with this ID. So if you want to learn more about gRPC and what you can do and how much time it can save you, that link is as well on the side, or you'll find it at grpc.io. Now, we get to walk through one more piece of code, and then we do a live demo of triggering the LRO. So all of you with me so far, or have I lost you? Great, the thumbs up looks good. All right. Kill okay, con kill okay. All right. So now, as I'm going into the compilation server, we're going to go straight down to the database, which we've seen already, so this becomes a lot easier to walk through. So, oh, that's my constant. Okay. So once more in the compilation, I create these transformers, which you can see is just a function to transform from my result set. But I want you to see how do I actually do my LROs, which is a little different. So let's scroll down to, I want to start from upsert, which I probably just passed. Okay, so the get book compile operation, this is just a basic SQL get. So I don't do it. This is, my controller needs a way to imitate CRUD operations. Create, read, update, delete. So what's my read? A basic SQL statement, select star, where its operation ID is equal to this. I bind it, and then I just ask my database client provider to execute that query. So I'm sure many of you here have interacted with the database. This must look very familiar from a code perspective. Now, when I get my book compile operations, you see right here, I'm doing an inner join on my book queue. I can trust that that statement is extremely optimized because I already did my interleaving. And so do remind me so I don't forget, so I can show you what the SQL schema looks like. It's pretty simple, but it's nice to see. And so it's going to get me the operations associated with the book compile. This is going to be important for when I say, hey, I just act a book compilation. Are there any more associated with this operation? Remember, I said latency matters. So that's where I want to be able to act, check to see if any records are left quickly, and then if not, mark it as complete. And then in the active book compilations here, this is where you see, hey, I want to know, are there any active ones at all left? So all I'm doing is filtering to make sure the status is not marked as complete or canceled. And cancel, you just remove all the child ones. And the upsert, this is where we're looking at it. Mutations again. So when I'm upserting, all I do is use the right builder, as we saw before. But remember, I want to insert child operations. And this is another tip that I'd prefer if you don't find out the hard way. So if it's a insert, I set the commit timestamp. Yes, I set the creation timestamp if it's completed. But I separate my child mutations into a separate list of mutations from my actual LRO. You cannot, in one transaction, create the LRO and the children. And you got to think about it. If I'm going to interleave in a parent, the parent must exist. Don't try to create the parent and the child at the same time. It doesn't make sense in your head. I'm sure it doesn't. So don't do it in code. So what you want to do is create the LRO in its own transaction first. Then after that, in a separate transaction, you can create the mutations that are dependent on that. So I wanted to point that out to you because if you try to do it, Spanner is going to give you an error and tell you exactly what I told you. It didn't make sense in your head. So when we look at the controller looks very much the same as everything else, but I want you to see how we orchestrate the ACK. Here it is. When I say ACK book compilation, I have the LRO ID and I have the book ID. So now what it comes in here, remove the book queue item, which is essentially a basic delete operation. Get that out the queue. Once that's done, I ask for, hey, get book queue item IDs for operations. That's going to eventually say, hey, get me the remaining queue items that are associated with this operation ID we just looked at. Then from here, I also do a separate query to say, ensure that the operation is still present. So I want to make my services and controllers idempotent, because what happens if I try to hack a book message for a compilation that's already done? You're already hacking a message that's hacked already. So why would I fail? Just make my service idempotent and return a basic 200. Do nothing. And so what I do here is, if the book queue is empty and the operation is still present, I still need to mark it as complete, well then, go ahead and mark it as complete. If it were the other way around, just do nothing. It's okay. It's not the end of the world. And so that's essentially what the controller looks like. You know what the service looks like. What we want to do now is show you the database schema and jump into a live cloud demo. So when you do go into my public GitHub repo, my code is organized like this. You see GitHub configs, and then you're going to see GCP configs, then you're going to see spanner compilations. And right here, that's the book compilations table. So remember, parent table, child table, interleaving. This is what it looks like in action. I created the basic table. Everything looks here like basic SQL to you. Up until this point, row deletion policy, completion timestamp older than 3 days. This is why I use spanner. I wanted the row deletion policy. Also, when you look at the book queue, everything, basic SQL, you learn nothing new except that you're like, whoo, I can do interleaving. Interleaving this parent and on delete cascade. Now, one other thing I need to mention about when you do an interleave. The child table, I should say, the parent table's primary key is a subset of the child table's primary key. So that is why the child table combines the operation ID and the book ID for its primary key, versus the parent table only just has the operation ID. Interleaving needs to know, what do I interleave on? I interleave on my operation ID, and that's why I have to combine those primary keys. So, that was a mouthful. Now we get to the nervous part of this presentation where I need cloud to represent. And so because of that, I made notes for myself. Let's go to my GitHub. So in my GitHub, my CloudBooks demo, most of what I've explained here, you will actually see in my README file. I've tried to break it down as much as possible. I probably should have gone here for the sequence diagram. So you'll see the folder layout and all these extra instructions that you can get to see. But it's meant to just be a point of reference for code snippets, really. So for book service, which is who is going to trigger this actual compilation, I had to make notes for myself, and I know, hey, I need to kubectl into my pod in order to call my gRPC endpoint. Why? Well, I have set up my gRPC, and I have proper IDs for it to get it. Google that ID, and I can get that, but I would have had to pay for an SSL certificate so I can access it properly through HTTPS, and I'm not going to pay for an SSL certificate for a demo. I mean, I like you guys, but I mean, I like money. So now, you have to remember your pods exist in a cluster, and for security purposes, you can't just send a query straight to your pod. You know, your cluster, you have to go into your cluster itself to send it to the pod, or use an ingress that pretty much gives your cluster an IP address and routes traffic to your pods behind of a load balancer. But that is definitely beyond the scope of this talk. So for now, what I do here, I'm going into my cluster and getting access to my pod. Now I have to go and reauthorize. Okay. Great, I'm into my pod. The next thing I need is, many of you may have known about the curl utility when you're making a post request. Well, there's gRPC URL, you know? So that's what I'm going to use. I know it might not be on my pod, so I added this command to essentially download and extract gRPC URL for me. So far, so good. Whew. Okay. And so now, what we're going to do, as a matter of fact, I'm going to do this command so you can see that, hey, it actually shows me that my service is being served on this pod. So if I do gRPC URL, plain text, my book service list, right here you can see it says, hey, book service is on this pod. You're good to go. So that's normally a good sign. And now we're going to trigger the LRO. And I am going to format that a bit on my screen here because we need the name for a book, some book ID. So I'm still fixing the paste script, but you're going to see it. So book, for those of you that will get the reference, you'll see it in the script just now. But I am going to name my book. It's a book about, how many of you know about One Punch Man? All right, you know what time it is. So now, notice it said no book with BK One Punch found. That was really quick. But now we get to look at Cloud Spanner. We're going to see, did it actually create an LRO, which it definitely did. I'm trying to see from here. Cloud build, where is it? Compute engine, artifact, I see it. Okay, there it is, Cloud Spanner. So I'm going to go ahead and close this for now, since we have a lot of what we need. So when you use Google Cloud, there's a free demo instance you can use, so that way you don't get charged for the first 90 days. To reiterate, I'm not a cloud DevOps engineer. I just know this because that's what I did. Now, if we look at book compilations, which is the table I hit, let's look at the query, chains, streams. Okay, I guess I have to query it. All right. Select star. All right. You gotta love yourself a little autocomplete, right? So now, right here, you can see what's today's date, the 4th, right? The creation timestamp. It was created right here, modified, and it was completed. Now, I want you to pay attention to the millisecond difference. You notice this. Barely any time passed between the 0649 and the 0651 operating status completed. That is great. If we were to look in the actual queue, you're going to notice that the book queue is empty, rightfully so, because we processed the book queue. The next thing that we need to look at is the actual book that was created. So I'm going back to my instance. I'm going to the books prod database because I keep my databases separate. And now, if we look at the books table, we can just click on data. I want to show you 2 ways to do this. And in data, you can see, obviously I tested this a lot, but right here is the one we made, the one for One Punch. And so there you go, end-to-end, long-running operations. Envision how you can employ this now for your architecture and the country and how you can make something slow seem pretty fast. And open for the questions. All right, so let's hit up with the questions. Oh, I promised to give you resources. There you go. Yeah. You can take a link to those are different resources. So you guys really got all of that? Another question? I mean, I'm not complaining. I'm just saying overall. Okay, most people are taking screenshots of the sources to actually. So, what's that? Oh, yeah, I suppose all the answers are there in the stats. But, oh, yeah, we have a question back there.
Hello. Does everything we saw is available on the, let's say, on the free, on the free trial of the Google Cloud?
Oh, on the free trial, I know Cloud Spanner is free. I have had my cloud instance up for a while, so I'm not sure when things stop being free. But it's really a pay-per-use. So it is pretty cheap because you're going to pay, like, for example, per pub sub message, you're going to pay based upon your Kubernetes. And like my Kubernetes cluster itself, which I didn't even show right here, I have like one replica itself just for each versus the 3 replicas. So I minimize my payments right there. But for the most part, you should be able to test a lot of it locally without even deploying on Kubernetes. The only thing that's absolutely needed that you would probably pay for is the Cloud Pub Sub. Because you can get your free spanner, you can run Docker images locally, you can set up your authentication, but Cloud Pub Sub, you have to get the messages through somehow. So that's what I would expect. Hopefully I'm wrong and you can get something lower cost, but not sure. Any other questions? I did show a bit of the gRPC and the juice. I've definitely played around with Spring a lot, and I've played around with Juice a lot, and maybe I'm biased, but I like the modular development of Juice just because I can separate my GitHub repos themselves and have, if you wanted to, if I was in a big company, you would want certain sub-packages to have different owners or people dedicated to them, and the whole Bazel approach of being able to say, hey, I'm going to build this package, build that package, and then Juice being able to just inject references from all these different packages. I think it makes more sense in my mind from a graph perspective than Spring. Spring is using the Spring and the Maven was a bit more involved for me, but I just wanted to see things as a graph, and I find that Juice and Bazel help me represent that graph. Remember I said everything in life can be solved with a graph? Yep, comes right back to that. All right, well, thank you so much for attending. Thank you.